Okay, so this is completing the square 3. So there's actually going to be a total of 4 of these videos, and this sort of gets into why. As far as solving by completing the square, the second video is solving by completing the square. That pretty much covers how to do that. And at the end of that video, I said that it's really kind of an unpopular way to solve equations. People would rather factor or use the quadratic formula. But another reason I cover it is you have to use completing the square for a lot of different things in Algebra 2 and in geometry, and pre-calc. You're going to use that technique. But the other reason I cover it is it kind of branches us off into these radical roots. So what I mean by that is, so far, everything we've done kind of looks like this down here. So we always get sort of two answers, like this one would be -3, -4. If we were graphing, those two solutions would become the roots of the parabola. It hits at -3 and -4. But the truth is, for most quadratics, you don't get nice, neat numbers like that. That only kind of works when you're factoring. So now with this lesson, we're going to start talking about things where factoring is not really going to work, and you have to use complete the square. So it's not really like a choice you're making. So as far as these go, well, just to review, the square root of 121, that's equal to 11. Okay, and as part of 8th grade math, or 7th grade sometimes, you learn that the square root of 12 has some value. So if I put this on a number line, the square root of 12 would be probably somewhere between 3 and 4, because it fits right between root 9 and root 16. But the truth of the matter is usually what we do is we put something like that in a calculator to approximate what it is. So the square root of 12 is around 3.46. And so they usually use these kind of squiggly equal signs to say, this isn't really exactly what it is. This is approximately what it is. The radical, of course, is the best way to put it. This is just a decimal approximation. So it's sort of like you can write 1/3, or you can write 0.33333. The decimal is just an approximation. It'd be better actually to just write the fraction, because that's exact. So before we jump into this, I want to talk about some of the numbers that you sort of run into when you're doing the work we're going to be doing today. So this is 3 root 12. And a lot of times when people look at things like this, they become very frightened. They run off. They go, oh, these are really weird, hard numbers. I can't do it. But as I just pointed out, this has a value. The square root of 12 is around 3.46. So this says 3 times the square root of 12. So this basically means the same thing as multiplying it by that. Okay, and again, that would just be sort of calculator math. I get 10.39 about. And then you can get binomials like this. So instead of it just multiplying, sometimes it says like 6 plus root 12. So this would be basically 6 plus, and we know root 12 is 3.46. And so this is going to be around 9.46. So these numbers we get, they do have some value. The reason I brought in this parabola here is a lot of times the roots are sort of decimals. They're not exactly on the line like the -3 and the -4 would be, okay? So I just wanted to kind of talk about that before we jumped into solving these, because you're going to get some answers that are going to look weird because of this, and I wanted you to understand what you were looking at. So now we'll do these. Now, as far as the work that I do, it's going to look exactly like yesterday. I'm going to start by moving the c term over. And then the next thing I'm going to do is I'm going to complete the square. So that means that half of the 4 is 2, and 2 squared is 4. So I'm going to be adding 4 to both sides of this equation. So then I have x squared minus 4x plus 4 on this side, and then I've got 59 on this side, right? Now this is a perfect square, so the square root of this and the square root of that, that's how you do it. And then it would be a -2, because there's a minus in the middle. And then I have this, okay? So here's where it's going to start to get different from yesterday. So I'm going to go ahead and square root this. And right away I'm going to put the plus minus here. So There isn't an integer that is the square root of 59. Like on the previous lesson yesterday, you usually have like a 64, a 1, a 25, something that would turn into a number. That's not the case here. So what happens is when I write this down, it ends up looking like this. Now I'm going to do the same stuff I normally do. I want to figure out what x is equal to. So I'm going to do the additive inverse, which means I'm going to take this negative 2 and put it over here, but remember it's a positive 2. And there you have what the answer is. Now, yesterday we got 2 equations out of this. You don't get 2 equations. These are actually a little bit less work because in my view, you can just write the answer like this. Everyone knows what that means. But because, as I pointed out, a lot of this is associated with graphing the quadratics and parabolas, you're going to get 2 answers. So oftentimes in math books and on worksheets, they won't write it like this, although they do just as much. But about half the books will actually list it out as 2 answers. So it'll say like 2 minus root 59 and 2 plus root 59. So instead of getting 2 numbers like 3 and 4, you get these binomial radicals. Okay, but as I pointed out, you could put this into a calculator and figure out approximately what these are. Okay, all right, so the next one here I'll do is just another example, is I will move the 98 to the other side. Then I will put a number here and here. So now I'm kind of shortening up the process here, but half of this is negative 6, and negative 6 squared is a positive 36. So I'm going to go ahead and add that there. And then I'm going to get 134 over here, and this is square root of that is n, square root of that is 6, and it's a minus again. So now I'm going to square that. Square root, this is a plus minus. And I have n minus 6 is equal to plus or minus the square root of 134. I'm going to do my additive inverse, so remember that's a plus 6. And that's it. I'm done. That's the answer. The only thing is, you know, again, you might have to rewrite it as 2 different numbers because a plus minus indicates that it's 2 different numbers. But this is kind of the shorthand way to do it, and for a lot of math teachers, this one would be fine. So that's how you do it. Nothing's different.